So for question 10.7, the copper pipe has an outer diameter of 40 mm and an inner diameter of 37 mm. It is tightly secured to the wall and three torque are applied to it to determine the absolute maximum shear stress developed in the pipe. So these are the figure for the problem 10.7.
So to solve this question, we have to level the diagram with ABCD at each point of the top and also the ending. Then we will separate it into segment AB, AC, and AD to calculate the torque TAB, TBC, and TCD. So to calculate it, we have to use the equation of equilibrium, which is the sum of the moment. So for the answer for the TAB is 80, and answer for the TBC is 60, and answer for TCD is 90. There's an important point that the direction of the torque that we calculate, so for example, at the TAB, uh, because we need to balance the equation, right? So of course it must be in the opposite direction with the AD. So the direction of TAB will point to the left. Then for the TBC, so because if we calculate it, the resultants, the direction will be also point to the right because 20 is also less than the 80. So the TBC will be point to the left so that the answer will be 0 at the end. Also for the TCD, so if we see that the sum of the number here will be point to the right, and so for the TCD we have to point to the left also to balance it.
As we get the maximum torque developed in the pipe is 90 Newton meters, so we just can calculate by using the formula maximum shear stress equal to torque max times radius of the pipe and divide by J. So the torque max is 90 Newton meter and time is with radius of the pipe. So based on the question, given the outer diameter is 0.04, so we just divide by 2, we can get 0.02. And all of this divide by J. Since this is a hollow pipe, so we just can calculate by using pi over 2 bracket C outer minus C inner, which is the C outer is 0.02. We just put the power of 4 and minus with 0.0185 power of 4. So 0.0185 we can get from the inner diameter, which is 0.037 divide by 2. So all of this we can get the answer 26.7 times 10 power of 6 Pascal. So we just simpler make it 26.7 megapascal.
So for question 10.51, the problem stated that the 50 mm diameter A992 steel shaft is subjected to the torque shown. Determine the angle of twist of the end A, and figure shown is the figure for problem 10.51.
Good morning, doctor. My name is Varshini. Metric number 229684. To solve this question, first we have to find diameter. The diameter given in the question is 50 millimeter. So we have to convert to meter. So the diameter will be 0.05 meter. For the shear modulus, we already know 75 GPa. So now we have to find polar moment of inertia. The formula for polar moment inertia is pi divided by 2. In bracket, diameter divided by 2. Diameter we already know 0.05. Close the bracket, power of 4. So the answer will get 6.1359 times 10 power of negative 7 meter power of 4. Okay, now we should find the torque from point A to D. The moment at point D equals to 0. So the formula to find TAD is TAD negative 800 equals to 0. Why negative 800 means at point A, the rod will rotate in clockwise direction. So the arrow will be on left side. That's why TAD negative 800 equals to 0. So the torque from point A to D equals to 800 Newton per meter. Next, we need to find torque from point C to D. Before that, we know the moment at point C equals to 0. So TCD minus 800 minus 200 equals to 0. So now why negative 200? Because at point D, the rod still rotate in clockwise direction. So the arrow on left side. That's why we need to put negative 200. So lastly, TCD is 1000 Newton per meter. Last but not least, now we have to find the torque from point C to B. The moment at point B equals to 0. So TBC plus 400 minus 200 minus 800 equals to 0. Why plus with 400? Because at point C, the rod rotate in anti-clockwise. So the arrow on right side. So that's why TBC plus with 400 minus 200 minus 800 equals to 0. So lastly, the TBC will get 600 Newton per meter.
Hello, my name is Tan Jingjuan, metric number 230393, and I'm going to present this part. This calculation shows how to find the angle of twist using the torsion formula. First, I use the equation, the sum of TL over JG. The powder moment of inertia, J, is calculated for a circular shaft using the formula pi over 2 times the radius to the 4th power. Given that the shear modulus G is 75 gigapascal, I substitute all the values, including the torques and length, into the equation. Finally, solving this gives the angle of twist as approximately negative 0.0274 radians. Thank you.